Welcome to the Ascend program, Unit 7, Streamline Workflow. This is Juan Riboldi. Today we're going to be talking about how to resolve capacity issues. This course focuses on facilitating process improvements in a practical and simple way. You will learn how to streamline processes to significantly increase output and production capacity. We will start by understanding how capacity affects the ability to get things done in an organization. When you look at how the work gets done in any organization, typically the answer is that it is done by the people. Yet people, by themselves, won't necessarily result in a productive activity. There is a need for people to be organized in order to perform. And then organizing requires a structure, a process, and a skill set. The structure defines who does what, the process defines the sequence of steps, and the skills defines the competencies required to do the job. So the combination of structure, processes, and skills is what builds organizational capacity. So where exactly would be the constraint if it is a capacity issue? If it is a structural problem, the questions you may want to answer are: do we have leaders over the core functions? Does everyone know who is their leader? And does everyone know their role and responsibilities for their particular jobs? If the answers to these questions are clear, we may conclude that the structure is not the problem. Now, if we suspect that processes are not efficient, the questions that we may want to answer are: does the work get done efficiently without extra steps? Does the workflow consistently flows across functions? And do we deliver consistent quality work? If the answer to these questions is affirmative, possibly the processes are working well. And finally, if we want to understand if we have a skills competency issue, then we may want to ask ourselves, do we have the right people in the key roles? Do people know how to do their jobs well? Are we constantly developing specialized skills? If the answers to these questions is affirmative, then we may have the correct competencies and skills to perform the work. If we assess that the work process is the issue, there are ways that we can tell and test whether the process is broken and needs improvement, and there are signs that tell us that the process is working and is not the problem. The process is a powerful lever for building capacity. Processes affect how the work gets done. A cumbersome or broken process is like driving a car on a highway under construction with frequent line mergers, detours, and closed sections. No matter how good is your car, the road conditions will determine your speed. Conversely, an efficient process is like a superhighway that allows traffic to flow at its best performance. So the ways to tell when a process needs improvement are: 1. Recurring errors, regardless of who is doing the job. 2. Delays, regardless of the original schedule. 3. Work usually takes longer than expected. 4. Consistent waste of resources. 5. Work gets over budget most of the time. 6. Redundancies and frequent duplication of effort. 7. Unclear expectations between groups, causing disconnects. 8. Work piles up in one area what is low in other areas, creating bottlenecks. 9. Quality and quantity of outputs is not predictable. There is a lot of variance on the output. And 10. It is not clear who is in charge of the process, so there's no clear process owner. These are 10 easy ways to assess whether the process is needing improvement. There are also signs that the process works and is not the problem. For example, if the process is well documented and there are current standard operating procedures, we know that there are defined steps to follow. 2. The process procedures produce predictable results based on the inputs provided. So the presence of predictable results assure us that processes are well implemented. And 3, there are measurable ways for tracking progress performance. Quality measures also tell us that the process is working well. An efficient process easily shows that the outputs are significantly greater than the inputs. The work process is adding value in a simple and efficient way. On the other hand, a broken process shows that outputs are very difficult to obtain. It takes a lot of maneuvering around to get the work done. There are many inefficiencies, errors, frustration, and redundancies, and those are clear signs that the process is broken and needs to be fixed. To illustrate the history of process improvement, we need to understand what happened after World War II in Japan. Japan was totally devastated after World War II. Many of the cities have been burned. Most of their industrial base had been shut down. Over 500 military officers committed suicide, and many more were executed. Japan was forbidden from ever having an army or lead war. As a result, the Japanese economy was devastated. The United States sent qualified workers, to help rebuild Japan after the war. Many of the industrial leaders that once had led factories during the war effort were now trying to figure out what to do next. Their companies had been completely closed, all their workers laid off, and their industrial base had been decimated. Besides, they had no customers per se at the time. So Japan needed to reinvent itself. Among the people that were sent to Japan to help with the reconstruction effort were some people with statistical background that have helped during the war years in the U.S. War Department to improve quality. Among them was Dr. Edward Deming. They started teaching the Japanese people processes and methods for quality improvement. These processes resonated with the Japanese philosophy of Kaizen, or continuous improvement. That could also mean a change for the better. These principles focus on how to make constant improvements on a work process to reduce variance and eliminate error. The Japanese proved to be very good at that and very quickly adopted these production processes in everything that they did, starting with the actual production of goods. The initial goods produced by Japan after the war were notorious for their poor quality. The only way that they could compete outside of Japan was by offering them at very low costs. And most people consider them below standards. What they didn't realize is that Japan was constantly improving the way that they were producing these goods. So a product built in 1 month was significantly improved a few months later. And that led to an evolution not only of the quality of the product, but the product itself. The Japanese were not just satisfied with improving the quality of the product, but they built quality in the entire manufacturing process, going all the way to the suppliers and all the way to the customers. That created a supply chain that was highly reliable and led to the concept of just-in-time inventory. Being forced by the size of the island to use space very efficiently, Japan could not warehouse large amounts of goods. They needed to have the economic power to buy large amounts of inventory. So just-in-time became a process of continuous improvement and supply chain management all the way from one end to the other. The Japanese took this concept even further to improving the management process. Everything from strategy to setting goals to allocating resources to measuring performance and evaluating the results that they were obtaining. So people themselves were being measured as part of the production activity. So these started to generate goods and services of superior quality, unheard of during that time. So when some of the initial vehicles came to the United States, people did not take the Japanese cars or motorcycles very seriously. But over a few decades, these cars became known for exemplars of great quality. At first, the American automakers took them with great contempt, knowing that they would never be able to compete with the American car makers. But as we well know, into the 80s, the quality of the Japanese products was so superior that American products had a very difficult time competing with them. So the Japanese, who were conquered by war, were now dominating the US economically. At one point, working for a plant at Ford Motor Company, they have been trying to instill for many years the concepts of quality and continuous improvement to the workers. But they failed to completely catch the vision or adopt the philosophy or really implement the practices fully. So as a consequence, the products were still of lesser quality. At one point, a plant manager, frustrated by the lack of quality of their cars, ordered the workers to blowtorch those cars in half to show the workers that they will not ship products of inferior quality. Engineers were asked to reverse engineer a car manufactured in Japan to understand how it was produced. So the story goes that they bought some Toyota Camrys, brought them to Detroit, disassembled them part for part, and they started measuring every part so they could engineer a car that was to be superior. Within a few weeks, the engineers came back to the managers to tell them that they did not have instruments of sufficient precision to measure the quality of these products, because according to their instruments, all these components were of the exact same dimensions without any margin of error. Such was the low variance that Japanese products have achieved. It became known as the 6 Sigma, or the standard for very low variance. All these concepts were brought together into a philosophy that became known as 6 Sigma. And the 6 Sigma approach has many methodologies for how to improve quality. There is a process to go about planning for quality improvement referred to as the DMAIC process. And there's also many other sub-components. Now, what we want to bring to you today is a simple fundamental concepts that make for essential continuous improvement. And one of them is to first measure the current process and see if it is in control or out of control. If the current process is producing results that are varying greatly between one time and another, your process is out of control. So there is a great opportunity for process improvement. The next thing to do is understanding the range of fluctuation of variance within the process to estimate what would be the ideal maximum output that the process could produce if everything was aligned perfectly, if everything was working in an ideal way. And this creates a theoretical target. So there we have how the process is currently working, and then we have a theoretical target. Then we go on to map the current process as is. Mapping the current process requires that we define every step of the process and who is responsible for that step, putting the people responsible for steps along horizontal lines and the tasks being linked together in the sequential order. As we create the as-is process, people gain a better realization of the redundancies or errors or situations that are prone to cause errors with the current process. This creates a greater awareness of how this could be improved. Now we compare the current output with the theoretical output that we want to achieve, and this gives us the ability to think of a new or better process. At that point, we bring a group of people to invent the should-be process. The should-be process is an idealized way of doing the work that approximates that theoretical output, assuming that everything is working perfectly well. Often, groups take several iterations to come with a really robust should-be process. And these iterations are still conceptual before any actual process is changed. These iterations give us the ability to conceptualize better and better ways of doing what we're doing. Typically, the should-be process would improve by about 300% the output of the current capacity. Then once you have the should-be process done, it would be important to test it. The first test is conceptual. Have people walk through the steps, make sure that they understand who will be doing what, and pressure test the process through extreme conditions and see how would you react when you have too much work or not enough resources or not enough materials to do what you need to do. And finally, when the process has been tested, it's time to deploy it. The deployment can be done all at once, could be done by phases, or could be done through a pilot group in a small area where it's cleaned up and then expanded throughout the organization. Depending on the risks and the need for the new process, you can choose what is the best way to roll it out. Once the process is rolled out, you would immediately experience about 3 times an improvement on the current production capacity from the old process. But the greater improvement happens even down the road as the new process is continuously improved. Create a feedback loop of measuring and assessing and brainstorming how to improve this process. As we optimize the process, we approximate that theoretical maximum output that we initially anticipated. In fact, many organizations have found that they can actually achieve what at one point seemed ideal, and then the bar of what is ideal has moved on. Now, back to today's environment of process improvement. There are many organizations, and much of the work that we do today that is an ongoing flow of work. Anything that produces an ongoing flow of work is an opportunity for process improvement. Process improvement will deliver a sustainable and significant gain over time. And these principles and practices will help any one of us to adopt process improvement methodology at work. So we're now going to describe simple tools to solve a process problem and to create continuous process improvement. The first step is to map the current process as is. Process improvements aim to deliver consistent outcomes such as high quality, fast turnaround, and low cost. To achieve these gains, we need to start by defining the current outputs from the existing process. Measure the outputs over a period of time, approximately 3 to 6 months, and notice the variance. A high variance that swings unpredictably means that the process is out of control. If the variance is relatively small and predictable, it means that the process is in control. Then, looking at the variance, estimate the ideal output, assuming everything works optimally. The ideal output is meant to be just that, an ideal. It is possibly not achievable in practical terms, but it gives us a target to shoot for, and it should be ambitious. It should assume everything is working optimally. Once we have measured the process variance and identified the ideal output, then we can start working with a cross-functional group of individuals who have practical hands-on experience working on the current process to map it out. The group represents subject matter experts in the process itself. They work in it day in and day out. Their task is to map the current process as is. If there is no formal process, there is no as-is model. Most often, however, there is a process that may not be well documented or may not follow the planned approach. Capture the way the work is actually getting done in the current system. The process scope is defined by the start and end points of the process. Project constraints are the guardrails within which the process functions, and may include elements such as existing resources, quality standards, or even legal regulations. To map the process, write down the steps in sequential order. Assign each step to a person or group. Documenting the process as is helps everyone understand who is doing what and in what order. After completing the as-is process map, analyze the obvious process inefficiencies, redundancies, or disconnects. Identify the areas that cause the most problems. This process review will help you build a case for significantly improving the existing process. While it is important to document the process as is, that activity should not consume more time than it deserves. Plan to save most of the time to create the new process as it should be. Creating the should-be process map begins by fostering a creative environment where people feel free to brainstorm. To ensure a breakthrough in creativity, you may even need to deploy breakout teams to work in parallel to engage in a competitive process design competition. Typically, the group ends up adopting the best ideas from different breakout groups to build the best possible process. As you map the should-be process, document the steps in sequential order with individuals or group who do the activities. This is not a time to clarify all the implications. As a facilitator, keep asking for a more efficient way to get things done, challenging the group's thinking to the very limit by asking questions. After you have achieved a draft of the new process, it is advisable to test the process. Initially, the team can test it by conceptually walking themselves through the process and ensuring that the new process eliminates the disconnects and does not add new ones. Leaders also need to approve of the new process. Eventually, have a live test that will show how the new process could be working. One of the clear indications that the new process is better than the old one should be the visual simplicity of the new process. By comparing and contrasting the as-is map with the should-be process map, we should see a significant reduction of steps with less people involved and more clarity. We should also see a significantly better output that the new process can deliver. As we run the process, both conceptually and through a live test, we may see a significant gain from the get-go. When the new process has been reviewed, tested, and is ready for deployment, it is time to consider what is the best way to roll out the new process. An effective process rollout ensures the maximum level of success and ease of adoption. To ensure that the new process is better than the previous one, there is a need to measure how process outputs are coming out from the beginning, analyze the results, and make additional improvements. This process of ongoing improvement can yield, in the end, even greater gains than the original gains from the design of the new process. This attitude of continuous improvement requires more focus on the process of rolling out the new process than the initial design. The continuous improvement process accounts for the greatest gains as the new process is redefined based on feedback. Recognizing the present situation, you may need to choose the best way to implement the new process. There are three main approaches to process implementation: a pilot test, a hard cutover, or by phases. The pilot test requires that we roll out the process in a small scale first to clean up the bugs before it's rolled out more fully across the organization. This approach works best when There are high risks if the new process fails or disrupts work. Or 2, there are new processes that may still have bugs and need to be worked out before full implementation. Or there is a high exposure if problems occur during implementation, or if there is time to clean up the process before it is in place for full use. Another approach to deploying a new process is called a hard cutover. This essentially means that on a set date, the new process is in place. This works best when there's high confidence that the changes will immediately improve the current situation. There's high leadership support for implementing the new process. There is strong demand for the changes by the end users, and there are ways to clean up the bugs in real time without significant consequences. Under those conditions, we recommend a hard cutover approach. Rolling out a process by phases means that the process incrementally is adopted by different parts of the organization. This works best when there are multiple groups with varying degrees of readiness. There is a need to gain the support of key groups before proceeding with full implementation. Or there are mixed levels of leadership support for the implementation, as well as if it is possible to adjust the process as it is implemented. When the new process is in place, the ongoing improvements can be even greater than the initial gains. The attitude requires more focus on continuous improvement than on getting the design to work right from the beginning. The continuous improvement process accounts for the greatest gains as new process is redefined based on feedback. I hope that you have found these practices for process improvement useful. Just to review the 5 key steps: assess the current process, measuring the current output, and determining whether the process is in control or out of control, and then determine the ideal output. Then, number 2, map the current process as is. Make sure that you involve all the players that are currently working in the process to describe what is currently taking place. Then create the process as it should be. This requires creative thinking and being challenged to reach that ideal output. Once you have mapped a new should-be process, it is time to decide what is the best way to roll out the process. This could be done through a pilot program, a hard cutover, or by phases. And finally, step number 5, continue to improve the process by measuring how the process is performing and making adjustments that produce increasingly better results. These 5 steps for process improvement will give you the power to simplify workflow and increase efficiency and continuously make improvements. I hope you have enjoyed this class, and I wish you a very good day.